You plug in, the cable locks, pumps veer, numbers climb. What's going on? Here's how a DC fast charger actually works. A DC side has the grid input, rectifier power modules, a controller, isolation and safety gear, cooling and connector, and software for communication and payment. When you connect, the car and charger talk over the control line using ISO or DIN protocol. They identify the car, shared limits, and decide the starting voltage and current. The BMS in the car is the bus. It requests how much current it wants and when to stop. Before full power, the charger gently raises the DC bus so the car's pack voltage and charger voltage match. Sensors check isolation to chassis. If everything looks safe, both sides close contactors. That loud click and high power can flow. Charging follows like this. It starts with constant current or CC phase. The charger supplies a steady current the BMS requests. Then there is the CV or constant voltage phase. Near the pack's maximum voltage, the charger caps voltage, current tapers to protect cells, and finish balancing. Power equals to the voltage times current. 400 volt times 350 amps equals to 140 kilowatts. 800 volts times 500 amps equals to 400 kilowatts. Higher voltage cars can get big kilowatt with the same current if the site supports it. High current heats cables and connector pins. Liquid cooled cables keep temperature safe so the charger can hold 300 to 500 amps without throttling on hot days. There are some limits that you might notice. Battery temperature, for instance. If it is too cold or too hot, you'll get lower current. The state of charge. The closer to the full, the slower you get in charging. The site limitation. Some pedestals share power. If two cars plug in, each may get less power. And you have car limits. Your EV's maximum voltage or current may cap speed. Isolation monitoring, ground fault detection, temperature sensors, and watchdog timers run continuously. Any anomaly detected, the BMS commands to reduce or stop, and contactors open. Regarding the payment, authorization happens via app, card, or plug and share. The site controller can load balance across stalls, manage utility demand charges, and schedule outputs. When the BMS sees voltage, current, temperature, and balances are good, it tapers to nearly zero and declares charging complete. Cables unlocks, and you're done. Want a one-page cheat sheet with this flow and the math? Download the free PDF. Link is in the description. Save it for your next road trip.